So if they gave you this chemical equation, and they asked you to write the rate law for it, it would be rate is equal to K constant. K is only affected by temperature. It's not affected by the concentrations. So that's an important thing to remember. K is not affected by the concentrations. But then you put the concentrations of the reactants. So the concentrations of the reactants would be this concentration of NH4 plus, and then NO2 minus, and so this would be the rate law. But a big thing to pay attention to is this is because they said in the problem they said it was second order, but if they didn't, then you'd actually need to find the exponents, and there's a number of strategies to find it. One, they have to give you data. If they give you an initial set of data, then you can figure it out. Otherwise, what you have to do is, if they give you the K constant, then you can actually know what the order is. And here's why. So if they gave you the rate constant, right? If they gave you the rate constant, which is 3.0 times 10 to the negative fourth, 1 over molarity times seconds, this actually gives you what K is. Why is that? Okay, so if we have K, rate is equal to molarity over seconds. So this entire expression has to equal that. So if and then each concentration is moles. Molarity. So this is molarity and this is molarity, because it's in concentration is in terms of molarity. So what does that mean? So if you multiply all this out, right? So 1 over ms times m squared, because m times m. So this would be m squared over ms, and then the 1m would cancel, and you're left with m over s. So that tells you that it is second order. Is m squared is second order, because so each one of these would be 1. So your rate order overall would be 2. And let's say they asked you to calculate this. Let's say they gave you concentrations for NH4. So for NH4 plus, they gave you the concentration of, they gave you 0.36 molarity, and for NO2 minus, they gave you 0.075 molarity. Now you actually have all the information you need to solve for rate, because you have the concentration for NH4, you have NO2 minus, you have the order, so it's just ones, so you actually don't need to do anything for that, and then rate constant. So now just plug in all your information. So K would be 3 times 10 to the negative fourth, 1 over ms. It's always a good practice to put all your units, even though it's like tedious. It can save you on a test from easy mistakes. And then NH4, they put in the concentration, 0.36 m. You look for the exponent, and it's just 1, so it's okay. And then 0.075. Once again, look at the order, see if you need to put it to an exponent, and you don't. So you multiply all this out, and it actually equals 8.1 times 10 to the negative sixth. And then the units would be molarity over seconds, because that's rate.